earthquake forecast for Puerto Rico. Dozens more large aftershocks are likely. We know that Puerto Rico is in an area of volcanic islands, and Puerto Rico is itself a volcanic island. This is on The Conversation by Professor Geophysics Department Head, Colorado State University, Richard Astor. Multiple strong and damaging earthquakes in southern Puerto Rico starting December 28, 2019, caused many injuries, collapsed numerous buildings, including multi-story school in the town of Guanica, and luckily it was empty at the time. These quakes are the most dangerous to strike Puerto Rico since 1918, and the island has been under a state of emergency since January 6, 2020. This flurry of quakes includes onshore and offshore events near the town of Indios and along Puerto Rico's southwestern coast. So far, it has included 11 foreshocks, smaller quakes that preceded the large one, or main shock, with magnitudes of 4 and greater. Major quakes occurred January 6 magnitude 5.8 and January 7 magnitude 6.4 main shock, followed by numerous large aftershocks. Seismologists like me are constantly working to better understand earthquakes, including advancing ways to help vulnerable communities before, during, and after damaging events. The physics of earthquakes are astoundingly complex, but our abilities to forecast future earthquakes during a strong sequence of events in real time is improving. Forecasting earthquakes is not a strict prediction. It's more like a weather forecast in which scientists estimate the likelihood of future earthquake activity based on quakes that have already occurred, using established statistical laws that govern earthquake behavior. An undersea fault zone. Puerto Rico spans a complex boundary between the Caribbean and North American tectonic plates, which are sliding past each other in this region at a relative speed of about 2 centimeters a year. So that's a lot. Over geologic time, this motion has created the Muertos Trough, 15,000-foot depression in the sea floor south of the island. This plate boundary is riddled with interconnected fault structures and the present activities occurring on and near at least 3 interrelated large faults. Faults are pre-existing weak zones between stronger rocks. In response to surprisingly small force stress changes, they rapidly slip to produce earthquakes. The hair-trigger nature of fault slip means that predicting the precise timing, location, and size of individual quakes is extremely challenging, if not impossible. During an earthquake sequence, changing stresses act on nearby fault systems as stress is gradually redistributed within the earth. This process generates thousands of protracted aftershocks. Many earthquake sequences simply start with the main shock, but it's not especially rare for scientists to recognize that after the fact that foreshocks were occurring before the main event. Improvements in earthquake instrumentation and analysis are helping scientists detect foreshocks more often, although we have not yet figured out how to recognize them in real time. Will one shock lead to another? Researchers have known for over a century that the rate of earthquakes following a main shock declines in a way that we can characterize systematically. There's also a well-established relationship between the magnitude of earthquakes and the relative number during an earthquake sequence. In most seismically active regions, for a decrease of 1 magnitude unit, say from 4 magnitude to 3 magnitude, people can expect to experience about 10 times as many 3s compared to 4s in any given period. Using such statistical relationships allow us to forecast the probability and sizes of future earthquakes while an earthquake sequence is underway. So put another way, if we're experiencing an aftershock sequence, we can project the future rate of earthquakes and what magnitudes we expect those earthquakes to have. For example, as of January 14, the U.S. Geological Survey forecast estimates a 3% chance of one or more quakes larger than magnitude 6.4 in Puerto Rico over the next 7 days. It also noted that the region should expect between 40 and 210 smaller quakes with magnitude 3 or larger, sizes that are likely to be felt during that time. With extended statistical modeling of earthquake sequences that include foreshock and aftershock probabilities, seismologists can forecast the likelihood of key earthquake scenarios to inform public safety efforts while earthquakes are occurring. For example, the USGS also estimated as of January 13 that there was an 81% chance that the largest shock had already occurred, namely the magnitude 6.4 on January 7. The agency calculated a 17% chance that a closely sized doublet 6.4 earthquake could yet occur. Recognizing in real time when a set of earthquakes is likely to be a foreshock sequence is a challenging and active area of earthquake forecasting research. Progress in the effective forecasting and communication of ongoing earthquake hazards could mean the difference between life and death for people in the Eastern Caribbean and other seismically active areas on an increasingly urbanized planet. Here we are at the Seismo Berkeley map of Puerto Rico. This is the Muertos Trough that we were talking about. And these are all the quakes today, the blue ones. One of the bigger ones is 3.4 at 14 kilometers depth, and was felt by 3 people reported to USGS. But these are only, the ones that are mapped here are only the ones that are, you can see how many there are. These are only the ones that are 2.5 and larger. If we go to all of them, you'll see that it's going to be blacked out with a tremendous amount of activity. All right, and let's take one of them, for example, the 3.1 at 14 kilometers depth, and we'll go to see the actual fault lines. As you can see, they don't have the shake maps, but that's okay. This is okay. We have one up here. As you can see, this whole thing, this whole area here is volcanic islands, the Antilles. And here we go. Okay, here we go. This is the historic quakes, as you can see. And this plate goes around this way, the Caribbean plate. And let's take out the historic seismicity so we can see the fault lines much better. This is it right here, as you can see. But we had another earthquake there. Let's pull out a little bit so we can see the other earthquake that we had today, right here in Venezuela. Trinidad, Tobago, Port of Spain, 5 magnitude in Venezuela, 15 felt it, and we can see that we have the same fault line of the, here we go, it's right here. This is the fault line that goes and curves around. This is horizontal, then it comes up. This is east-west, and it comes up this way to the north and flanks above Puerto Rico, as you can see. So I wouldn't be surprised if the pressure here, of course, all this acts together. It's one fault, one plate, I should say. So, okay, this is one plate acting, having the pressure going around the plate, the fault of the plate. And this is another one, of course, 3.4, Virgin Islands, 59 kilometers depth. And this one is at, I think it was deep, yes, 91 kilometers depth in Venezuela. So you can see that Puerto Rico is still very, very active. And because of the fact that they have ongoing quakes, unfortunately the people are living out as much as they can. They're not going in the buildings because these quakes have not stopped since the beginning of January. They're ongoing every single day. This is the situation every single day. These are the past week. The blue are the past day. So all these piling up on each other, the blue are the past day, and the yellow are the past week. And then they get rid of the yellow, and it's every week that they update them. Otherwise, the whole thing would be blacked out with quake. Let's go back to the seismicity, historic seismicity, as you can see. And we also have it's a volcanic area. There's magma underneath here as well. So that's the situation with Puerto Rico. It's still very active. This is the active area of it. Only that area. So something must be going on there. I'm sure that they have some kind of, let's go back to this, the map, and go in, take off the seismicity, and, okay, that's okay. The historic seismicity. I want to see yeah, well, there's obviously here, this thing, there's seamounts there as well, as you can see. Seamounts. And that's where all the action was for the past 2 months, 2+ months. Okay, it doesn't go in anymore. But you can see islands here and a peninsula there. That's it. And it's a volcanic island, as we had said before. In an area of volcanic islands. Wherever you have these tectonic movements, of course, you have subduction, you have volcanic activity as well. So I'll leave links below for you for this. Thank you. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.